Alright, so this is not section anything. We're just going to call it, this is worksheet section, what is it, 8.4? And right now we're working on page 27. Alright, so if you want to go back and look at this, maybe it'll help you out. Alright, so what I want to do, let's do number 2, alright, because that was a little bit more complicated. I didn't do number 2 in the other class. And here's another thing. If you want to look at some other problems, what I'm going to try to do in this class is pick a couple different problems that we did not do during 4th period. Let's just do the problem. This is L, this is N, this is M. Alright, it says little l is 12, so that's this one right here, because it's across from capital L, angle L. It says m is 12 times the square root of 3, so this right here is 12 square root of 3, and n is 24, so this is 24. Alright. Well, if you think of this, what kind of triangle is this? This is actually a special triangle. Did you recognize that? Because look, this is the shortest side out of all these, isn't it? It's smaller than 24, and it's smaller than this, because 12 times the square root of 3 is 12 times 1 point something. So yeah, so this will be the smallest. So look, the hypotenuse is twice as big as the shortest side, isn't it? And guess what else? The longer side is what? The square root of 3 times the short side. What kind of triangle is this? It's a 30, 60, 90 triangle, isn't it? So which one is the 30? Which angle would be the 30? Which is L. Right, so this would be 30, wouldn't it? This would be 60, and this would be 90. Right, now you didn't have to find that. I don't know, I just looked at it, and it occurred to me. Did it occur to anybody else that that might have been 30, 60, 90? Okay. Now that really doesn't help you all that much. It's actually it's a little bit more interesting if you know a little bit higher level trig. But for you guys, you probably don't care. But anyway, let's do this. What are we trying to do? We're trying to find the sine, cosine, and tangent of these two angles, aren't we? Of L. So let's write that down. Let's do that different color here. So let's go the sine of angle L, the cosine, and the tangent, right, of angle L. Sometimes the L's look like angle symbols, don't they? But that's an L. So let's do the sine of this angle right here. So let's write them down. So, ka, toa. You got that memorized now, don't you? All right. So you should eventually wean yourself from writing this down every single time. You should. The more you do these, the more you get familiar with it, and you just think about it. You don't have to see it. But at first, write it down. Okay. Definitely write it down. So the sine is the opposite over the hypotenuse. So what's opposite angle L? 12 over the hypotenuse, which is 24. Always reduce it. 12 goes into both of those. 1 over 2. So there you go. That was an easine one. All right. What about the cosine, though? The cosine is the adjacent over the hypotenuse. Right here. Adjacent over. Which one's the adjacent to angle L?
24.
Is it? Well, it is. I mean, technically, this side is adjacent to this angle, but it's the hypotenuse, right? So I call this the hypotenuse. What's the side that I call the adjacent side of my right triangle? 12 square root of 3. So it's adjacent over hypotenuse. So it's 12 square root of 3 over what? The hypotenuse, which is 24. Now watch. This wasn't that hard. 12 goes into that once, 12 goes into that twice. So look what I have. I got a square root of 3 on top, and I have a 2 on the bottom. Make sense? You didn't have to know anything about square roots or anything, did you? To figure that out. Nope, you didn't at all. So let's do the tangent. The tangent, now this one's a little bit more complicated. The tangent is the opposite over the adjacent. So what's opposite angle L? 12. What's adjacent to angle L? 12 square root of 3. So look, simplify this. What cancels here? The 12s. That goes once, right? And that goes once. So I've got 1 over the square root of 3. Now normally I said that at this point I would let you keep it like this, with a square root on the bottom. Alright? But remember what I said we were going to do? We're going to learn to simplify these things. And we've gone through this enough. I don't think it's that difficult for you to be able to handle. So how do I get rid of this? Say it, Isaiah. What is it? Yep, square root of 3 over square root of 3. Okay, because basically you're multiplying by 1 here, aren't you? And If you know that, the rest is actually pretty easy. What's 1 times the square root of 3? It's just the square root of 3. We talked about this a bunch yesterday. What's the square root of 3 times the square root of 3? It's just 3. So that's how I want you to write your answer. It's exactly the same value as this, but why don't we like to write it like this? Because somebody somewhere sometimes told us what? That you can't have square root in the denominator, okay? I don't know. Somebody made that up, all right? Long time ago. And so a lot of teachers don't let you have it like that. Normally, I probably wouldn't care, but there are reasons. I'm trying to... You don't see, but I do, okay? Because I know what you're going to see later on. For a lot of you guys, you're going to be taking Algebra 2, and at the end of your Algebra 2 class, you'll be doing a lot of trig. All right, probably the last half of the last marking period. Okay, you'll be doing a lot of trig and stuff that's a little more complicated than what we're doing here. And they're going to make you in Algebra 2 write the answer like this. So I want you to be prepared for that. So even though this is kind of like more of an algebra topic, I want you to be ready next year. So when they say, here's the phrase that they use. I'm not going to make you memorize this, but just so maybe it sticks in your head a little bit. They call it rationalizing the denominator. So we're going to say, rationalize the denominator. Denominator. Okay. All right, rationalize the denominator. What does that mean? That means get rid of the square root in the bottom and put it up top. Everybody see that? And this is the method that we do it. We've done this several times, haven't we? Not just once, but we've done it a bunch of times, actually. And we'll probably do it a few more times after this. All right, so make sure you know how to do this. It's not that hard, is it? So those are the answers that I circled right there. They're the ones that I read off to you. All right, now let's do the rest of them a little quicker. Let's do angle M this time. So we got to do the sine, cosine, and tangent of angle M. To tell you the truth, we learned a little trick yesterday. Do you remember that little trick? The sine of this angle is going to be the same as the what? The cosine, right. It's the opposite sine, right? So it's the opposite trig function. So the cosine of this angle, let's do this. The cosine of this angle is the sine of this angle, right? So look, I want to find the sine of M. So what do I look for over here? The cosine of L, right? So that should be square root of 3 over 2. So guess what this is? Square root of 3 over 2. That's kind of nice to do, isn't it? If you really wanted to, what could you do? You could go opposite over hypotenuse. Opposite over hypotenuse. 12 over square root of 3, or sorry, 12 times the square root of 3 over 24. It's the exact same thing, isn't it? All right? It's just a little bit quicker, a little nicer. So what about the cosine of M? The cosine of this angle is the same as the what? The sine of the other angle. So what is it? It's a half. Boom. You can go a half. What about the tangent, though? The tangent of this angle is equal to the inverse of the tangent of this angle. So this one was, let's use this one. It was 1 over the square root of 3. What's the reciprocal, or the inverse of this? It's the square root of 3 over 1. So guess what this is? It's just the square root of 3. That's kind of nice, wasn't it? So you find one angle, find the sine, cosine, tangent of one angle. You should be able to find the sine, cosine, tangent of the other one just by looking at these answers, right? And just doing what we said. Yep. That's a different story. Okay. You can find the sine, cosine, and tangent of a right angle, but we're not going to do that now. All right. So we're just using these two right here. I don't want to get into that right now. That's more of an Algebra 2 topic. Okay. Does that make sense? Tell you what, just for fun, let's do the tangent of M the old-fashioned way. Right here. What is the tangent of this? The tangent is the opposite over the adjacent, isn't it? So it's opposite, which is 12 square root of 3, over the adjacent. What's the adjacent to angle M? It's 12. No, 24 is the hypotenuse. Okay, 12 is the adjacent. So look what happens. Bang, bang. They go. Look what I got. Square root of 3. Just like I said it was going to be, didn't I? All right, isn't that nice? All right, so it came out just the way I said it would. I'm not lying to you. They're not really tricks or anything. It's just understanding that the cosine of this angle is the same as the sine of the other angle. The sine of this angle M is the same as the cosine of angle L. If I take the tangent of this, it's just the inverse, right? You just flip the answer to this. This was 1 over the square root of 3, so what's this going to be? Square root of 3 over 1, or just square root of 3. All right, enough of that. Does that make sense? All right. Those particular problems probably won't get any more difficult than what we just did right there. It's probably about as hard as they'll get. All right. Yeah. 3, 4, 5. Was there 3? Oh, number 3, 4, and 5. Yeah, I thought you meant 3, 4, 5 triangles. Yeah, absolutely. That's what we're going to do. I'm trying to remember which one we did in the other class. I don't know. Pick one. I don't care. Which one do you want to do? 5? All right, so let's flip this thing around. Uh-oh, what did I just do? Why did I get rid of that? There we go. All right, I don't know what I did. So let's go to this. Let's go to this. Flip it. There we go. And make it a little bit bigger so you can see it. All right, this is a right triangle. And let's see what they give you. They give you the hypotenuse is 32. The angle is 41. And they ask for this side right here. I did this in my other class. I'm going to do it in here as well. On these worksheets, they made it kind of easy for you because they just said solve for one thing. But if I gave you problems from the book, which I may eventually do just to review some of this for you, sometimes the problems will say this. And I may actually have this on a test. Right? It'll say solve the triangle. What do you mean solve the triangle? Well, basically you find all the missing stuff. Okay, so x is missing, right? This side right here is missing. Let's call it something. Let's call it y. Is that all right? And this angle right here is missing. Let's call this A, call this B, and call this C. All right? So what if I asked you? Now, I understand that on the homework that I gave you, on that worksheet, they only ask you to solve for x, and then you're done. But we're going to just take it a step further. Is that all right? And then find the other two sides. Find, or not the other two, but the other side and the other angle. What's probably the easiest out of all that stuff? The angle. Right. How do you find that other angle right here? From? Yeah, that's the best way. That's the most efficient way to do it. It seems like even though I say this over and over and over again, people still say 180 minus 90 minus 41, right? But look, what's 180 minus 90? 90. So every single time, these two angles will always add up to 90 degrees, won't they? Yeah. On a right triangle? So instead of going 180 minus 90 minus 41, why don't we do it in one step and just say 90 minus 41? So what is 90 minus 41? It's 49, I believe, right? Yeah. So, all right, so we found angle B. So that's one thing out of the way. Now let's solve for x, and then we'll solve for y. And we're going to do these by our trig functions. It's really the only way to find what x is. All right, so let's do this. Let's go a different color here. Well, let's see. We're trying to solve for x, correct? And we know what? What side do we know? 32, the hypotenuse, right? So this is the adjacent. Now, which angle do you want to use? You could use 49 if you wanted to, right? Or you could use 41. It doesn't make any difference. Let's just stick with the one that they gave us, okay? Let's stick with 41. So I'm using this angle right here. What is side x to angle 41? It's adjacent, isn't it? All right, so I've got adjacent. And then what is the 32? You already said it once. It's hypotenuse. So I've got adjacent and I've got hypotenuse. Which trig function do we use? You guys paying attention? It's the cosine, right? Because it's CAH, right? It's SOHCAHTOA. CAH, cosine. So that's how we know to use the cosine. People ask me all the time after I go over this over and over and over again, how do you know which one to use? Well, it all depends on what side they give you and what side you're trying to find, right? And what angle you're using. So if I'm using this angle and I'm trying to find this side and they give me this side, I've got adjacent, hypotenuse, that's cosine. Am I right? Okay. So take the cosine of the angle. Which angle are we talking about? 41, right. The cosine of 41 is equal to the adjacent over the hypotenuse. X over 32. Good. And now we're just ready to do a little bit of math. How do we get rid of that 32? That's right. Everybody watching? Because I want to get x by itself, don't I? So 32 is being divided. I do the opposite of division, which is multiplication. So multiply that by 32, and they'll cancel out. What do I have to do to the other side? That's right. Multiply that by 32 as well. Everybody see that? So that's what x is equal to. Now, what do I do with this? Do I write my answer like this? No. Put it where? The calculator. Okay? So get out your cool calculator. And let's put some numbers in. Now, in this particular calculator, this is how you do it. And I'll show you how to do it on those TI-30XAs or whatever they're called. All right, so watch. I'm going to go 32, and then I hit cosine, I hit 41. So basically, it's exactly like it's written right here on this type of calculator. All right, hit enter. Boom, there it is, 24. Now, this says to round it to two places, doesn't it? So 24.15, do I round that up or keep it the same? Keep it the same. Keep it 15, right. Okay, so it's 24.15. So x is 24.15. That's all you do to solve for x. Why was it next to it? Because I'm taking the cosine of 41 degrees. Right? Why are you looking at me like that? You don't have any idea what that means, do you? Because look, you take the cosine or the sine of the tangent of the angle. If I'm working with this angle, I got to figure out which ratio do I want to use, right? I got three different ratios. I've got a cosine ratio, which means what? Adjacent over hypotenuse. I have a sine ratio, which means what? Opposite over hypotenuse. I have a tangent ratio, which means opposite over adjacent. Which one of those ratios am I going to use? The cosine. Why? Because I have an adjacent side and I have a hypotenuse. Okay, so that's why I use the cosine. I take the cosine of that particular angle. Not just of any angle in the world, of this angle right here. Because this is adjacent to this angle and this is hypotenuse. So I take the cosine of this angle. Cosine of the angle. That's just a decimal. Watch. If I just hit cosine of 41 degrees, right? Punch that in there. What is it? It's 0.75 blah blah blah. What in the world does that mean? That means any triangle, any right triangle with a 41 degree angle, if I was to take the adjacent side and divide it by the hypotenuse, no matter how big or how small my triangle is, everybody listening? Listen, this is important. Isaiah, get your head up, please. Sit all the way up. Back up against the chair. There you go. That'll help you. Blake, sit up. Back up against the chair. David, sit up. All right, let's pay attention. Okay, let's lock in. Let's focus. What this means right here is the cosine of 41 degrees means if I take the adjacent side and divide it by the hypotenuse of a 41 degree angle, it will always come up with 0.75. It'll always, no matter how big or how small my triangle is, if I take the adjacent side and divide it by the hypotenuse, if I have a right triangle with a 41 degree angle in there, I'll always get this ratio. And it's about 3/4, isn't it? What did I do? There you go. Okay, isn't it about 3/4, 0.75? So every single time I have a 41 degree angle, this is going to be approximately, what, 3 to 4. Approximately. Not exactly, because it's 0.75 blah blah blah. But that's what it means. I don't know if that helps you understand that anymore, but that's what we do. Alright? So let's do another one. Let's do y. Yeah. Okay, on a regular calculator, like on a TI 30 whatever. Actually, it's not just a whatever, because the TI, let's see, the TI 30X, what's your say, X2A? Or XA, right? It just says XA. So watch, if you have a calculator, I think most people in here have TIs, don't they, Texas Instrument? TI 30XA. If you have a TI 30XA, what you would do, I do this first. But you don't hit cosine first. Alright? On these calculators, you always hit the number, then you hit the function. Alright? So like if you wanted to square something, hit a number, you square it. If you want to take the square root, hit the number, hit square root. You follow me? So if you want to take the cosine of 41, what do? You hit 41, and then you hit what? The cosine. That'll give you that decimal. That'll give you that 0.75 blah blah blah. Then what do you do with that? Multiply it by 32. Right? So that's what you would do on a Texas Instrument 30XA. Now, does anybody have like a, if I remember right, a TI 30X2S? Anybody have that in here? I think I asked that the other day. I don't think anybody did. Because in my other class, there's like 3 of them that have this. But this is kind of like, you know, here's your calculator. You know how on the 30XA, it's just got one line of type on there? Well, on the 2S, it's a little wider, so you can actually have one line and 2 lines. If you have a calculator that looks like that, where you can actually type in 2 lines of stuff, there you go, right there. Everybody, show it, Isaiah. If you have a calculator that looks like that, then you actually do the stuff, you put it in the same order that we would do on this calculator. Everybody with me on that? So Isaiah, on your calculator, you would put stuff in the same exact order that we do on this graphing calculator. But if you have this 30XA, you kind of do it in the opposite order. You put the number in first, and then you take the the function of it. Okay? Does that make sense? You got to practice. Listen, I told my last class this. You have to practice using your calculator. That sounds kind of weird because you just figure, oh, anybody knows how to use a calculator. But different calculators do things a little differently. As far as what you punch into them. Be familiar with it. Don't show up the day of a quiz or a test and borrow somebody else's calculator that's different than the one you're used to, because it's going to mess you all up. Make sure that you practice on your calculator, and then when it comes to a test or a quiz, make sure that you use that same exact calculator so you know what you're doing. All right, enough of that. Let's do what's the choices? 6, 7, or 8? Which one? 7? Okay. Let's draw it out a little bit here. Let's rotate it. It's pretty close, doesn't it, to number 7? Alright, right angle, and I've got 25 and 30. And it says solve for angle B, but just for fun, guess what we're going to do? Solve all of them. Okay, solve the what? What do they say? Solve the triangle. So when it says solve the triangle, it means find all the missing parts, okay? We'll put an X right there. So we've got to find side X, we have to find angle B, and what else?
C.
Angle C, all right? Really, you only have to do the trig functions one time on this. What can we find without doing any trig functions whatsoever? Now, you got to use a trig function to find the angle. X. What do you use to find X? I've got a right triangle. I've got two sides. So what is it? You said it. Yeah, that's what I want you to say. Okay, it's the Pythagorean theorem. Okay, you're going to use Pythagorean theorem to solve for X. Right? Because I know two sides of my right triangle. Zach, you getting all this? Javon? You with me? All right, sit up straight. Sit up straight. Write some stuff down. Okay, if you're just sitting there staring off into space, right, you're going to nod off. So write some stuff down, jot this down, even if you did it earlier. I don't care. Flip the page over, redraw the triangle, do stuff to keep yourself awake, okay? You have got to be stronger than this, all right? You can overcome. I know it's dreary outside, it's rainy, and it's dark in here. We got the lights on and all that kind of stuff. I get it. But you've got to force yourself, all right? Have a little discipline, and let's pay attention to what we're doing. Watch this. If I wanted to solve for X, I could do Pythagorean theorem. So I'm going to go X squared, what? Am I going to go equals or am I going to go plus? Sure about that? Just because I said sure about that? It's plus. Look, because you take the two legs, you square the two legs and add them up, right? And that equals the hypotenuse squared. That's the c, right? The little c, right? In our theorem. So it's x squared plus what? 25 squared equals what? 30 squared. All right, this is what's by itself. It's the two legs. You square and you add them up. So what I'm going to do, I'm going to subtract the 25 squared from both sides. Look, don't put 30 squared, 900, and 25 squared, whatever that is. What's that, 225 or whatever? No, it's not that. If 625, yeah. Don't put those numbers in right now. Do it like this. Do it in one shot in your calculator. What am I going to do with this? Subtract the 25 squared from both sides. Everybody see that? So I got rid of this. And then how do I get x by itself? What do I do to that square root? Square root it, right. So I take the square root of all this. So look, chuck all that in your calculator in one shot. I think it's a lot easier, to tell you the truth, right? A lot more efficient. So how do we do this on this calculator? Well, hit square root first. Okay, I can hit second function on this one. Gives you parentheses. Then I put the stuff inside the square root. 30 squared minus 25 squared. Right? I close the parentheses because it's telling me to do what? Square rooting everything in that parentheses. Then all I got to do is hit what? Enter or equal, and there it is. And I'm going to round it to the nearest tenth, let's say. So what would that be? 16.6. So x equals 16 point. Actually, they tell you to write down 2 decimal places. So let's go 5.8. Is that all right? 5.8. Well, look, if you had one of those other calculators with the 30XA, right? Getting these numbers down now. Look, just go 30 squared minus 25 squared, hit equals, and then what do you think you do with that big number? Hit the square root, right? You always put the number in first, and then you hit the function. Remember what I said? All right, so 30 squared minus 25 squared equals, it gives you a big old number, And then you take the square root of that number, right? And on those calculators, you don't have to hit second function, do you? There's actual square root button right on there. So you hit the square root button, bang, you should get the exact same number, shouldn't you? All right, so we got one side. That's 16.58. That's all the sides. That was the only missing sides. That's one we did. So let's solve for this angle right here. All right. Well, this is the angle that we're going to use. Now we do know this side, but let's do this. Let's just let's use the two sides that they gave us originally instead of putting it in a decimal. Okay. So if I want to find this angle right here, what two sides do I know? What two sides did they give me? I know adjacent, which is what, 25, right? And I know hypotenuse. So if I know adjacent and hypotenuse, which trig function? Right. It's not ka, it's the cosine. All right. You use the ka to help you remember, but we say cosine, correct?
Yeah.
All right. So watch what we do. We take the cosine of angle B is equal to adjacent over hypotenuse. Which one's adjacent? 25. No, this is the hypotenuse. Okay. 30 is the hypotenuse. Why is it the hypotenuse? How do you know it? It's opposite the right angle. It's because it's opposite the right angle. That's what I've always told you, okay? That it's opposite the right angle. That's the hypotenuse. Now look, what in the world do we do here? We have to solve for the angle. You don't really have to because we're going to put it into a calculator. Inverse stuff. Is that what you said? The inverse stuff? Yeah, the inverse stuff. All right, so what we do is we don't divide by the cosine. That's not really a number at all. But we take the inverse of the cosine to get rid of it. So B is by itself. How do I write the inverse of the cosine? I have a little special way to write it. Cosine what? To the negative first. That's how I write the inverse of the cosine. We've talked about that, haven't we? Some of you guys are looking at this like I'm speaking another language. Okay, we have talked about this before. So look, that's the inverse cosine. See what I did? I got rid of it here, and then I did the same thing on the right side. Took the inverse cosine of this, took the inverse cosine of this. Why in the world do I even want to write it like this? Because it looks like that where? On the calculator, exactly right. Okay, let's clear this. Look, inverse cosine. See where cosine is? It's got a cosine to the negative first. That's why I like to write it like this, because it looks just like that on the calculator. So what do? Hit second function cosine. See, it is right there. Cosine of the negative first. Of what? 25. Hit second function cosine. Right? It's in yellow. It's right there. Right? And then hit equals. Boom. There you go. See, I didn't have to reduce 25 over 30, did I? The calculator does all that for you. So 33, and this is rounding to the nearest tenth. So what would this round to if I rounded to the nearest tenth? 0.6. That's right. So this angle right here is 33.6 degrees. That's not hard at all, is it? I don't think so. Look, get rid of the cosine by taking the inverse cosine. So you put that in the calculator, hit inverse cosine. Now watch, if you're using a TI, what is it called again? TI-30XA, that's what it is, TI-30XA, then you would do this. Remember, you always do the number first, then you hit the function. So I would go 25 over 30, hit equals. Do it if you have that calculator. Punch it in there. 25 divided by 30 equals. And then guess what you hit? Not cosine. Look, this is not cosine. What is this? It says inverse cosine. So second function cosine. Right? You don't hit the cosine. It's not cosine. It's the inverse cosine. So you hit 25 over 30 equals. You get some fraction, right? Okay. Then you hit second function cosine. Bang. You should get 33.6. You don't even have to hit equals, do you? You get it right there. Make sure you know how to use your calculator. All right. One last thing and we'll be done. Let's find angle C, but let's do it real easy without any trig at all. How would you do that really easy without any trig? That's it. 90 minus 33.6. You got it. And that would be what? 56.4. Is that right? Did I do that right? Okay, 56.4. And that would be this angle right here. Now I know on the worksheet that I gave you, I didn't ask you to solve the triangle, did I? I just went a little bit above and beyond what I asked you to do earlier. But I think it's good to be able to do those things. So there you go. Figured out how to do the inverse cosine. Now look, the only time you do inverse cosine or inverse sine or inverse tangent is when you're finding what? An angle. That's right. That's the only time that you do that inverse stuff. If you're finding the side, like we did over here, solve for x or solve for y, then oh, we never did solve for y up here, did we?
No.
We need to. Let's do that real quick, and we'll be done. So look, I've got 32. I've got this. This is opposite. This is hypotenuse. Which trig function do you want to use? It's the only one I can use. I don't want to use TOA. Well, I know what x is, but let's use the original numbers that they gave us. So the sine of 41 equals opposite over hypotenuse. Opposite is y. Hypotenuse is 32. Look, multiply both sides by 32, right? That'll go away. That goes right here. Plug that into your calculator, and you're good to go. There's no inverse here, though, is there?
No.
All right, because we're finding the length of a side. So all I do is hit 32 sine of 41. I always like to close that parentheses. I don't think you really have to, but I like to do that anyway. And then there you go. So it's about, what, 20.99, right? I said two places, didn't I? So 20.99. Make sense?
Yeah.
What was this one? What was x? 24.15. Let's just make sure that makes sense. 32 is the biggest side, isn't it? Well, it's opposite the right angle, so that's cool. What's the smallest angle? 41. Is that the smallest side? Yep. So the smallest side should be opposite the smallest angle, and the longest side, 32, should be opposite the biggest angle. Make sense? If it doesn't work out that way, you did something wrong. It's a nice little way to check to see if you did it right or not. Okay. I don't have time to do the con thing, but I would encourage you to go to one of those sites, Khan Academy or something like that. I'll tell you what, let's look at this real quick. I found this guy actually, I don't know what you call it on YouTube, friended me or something like that. It's not really friending, I forget what they call it, but yeah, like subscribed, or I subscribed to him, or I don't know, whatever.
Do you want those sheets?
But yeah, I do want those. So get those out. Anyway, I'll show you that another time. Forget that. I'll show you another time. But anyway, he actually commented on mine, and I looked at his page, and he does a lot of the same stuff that Khan does, except he doesn't use like a graphics tablet. He just actually writes on a piece of paper with a video camera. It's a little bit low rent, but it's good. I shouldn't say that. He might be watching this video. But he actually asked me what program I use and all that kind of stuff. What's that? That's fine. So anyway, but he does a good job, though. Okay, he explains things very well. So I'll show you what his site is tomorrow, so you can look at it.